NASA was founded more than 60 years ago. We had questions about the universe that we had been asking since the first time we looked up into the night sky. In the 6 decades since, NASA, along with international partners and thousands of researchers, has used a full fleet of telescopes and satellites to expand our understanding of the universe. NASA scientists have been studying the evolution of the universe from the Big Bang to the present, from the early probes of the 1950s and 1960s to the great telescopes of the 1990s and 21st century. However, NASA scientists recently discovered something massive lurking in the vastness of the cosmos, something even bigger than our own Milky Way. So join us in today's video as we discuss this massive structure and some other recent NASA discoveries. The Milky Way is a large galaxy that houses our solar system, the Sun, the Earth, and the planets that orbit it. In a first-of-its-kind discovery, astronomers at the University of Alabama in Huntsville, UAH, discovered a scientifically mysterious, isolated cloud larger than the Milky Way in a no-man's land for galaxies. The orphan, or lonely cloud, is made up of hot gas with temperatures ranging from 10,000 to 10 million degrees Kelvin and a total mass 10 billion times that of the Sun. This makes it more massive than the mass of small galaxies. While its exact origins are unknown, astronomers believe the lonely cloud is held together by gravitational forces and formed from one of the nearby galaxy clusters before being torn apart from within. The mystery surrounding this theory is that astronomers are unable to explain how it is still in existence if this is the story behind its formation, as the massive cloud would have dissipated by now. They currently believe the cloud could be hundreds of millions of years old, and that its survival since being separated from its host galaxy could be due to surrounding magnetic fields. Even more enigmatic is the fact that the cloud is not associated with any galaxy and is located in a no-land galaxies. When the host galaxy is soaring in the hot gas at 1,000 to 2,000 kilometers per second, the gas in the cloud is removed by ram pressure from the hot gas in the cluster. That's roughly 50 times faster than Earth's orbital speed around the Sun. That level of force can rip the interstellar medium from a galaxy, and in this case, the researchers discovered that the cloud's temperature is consistent with its origin in a galaxy. The cloud was discovered using the European Space Agency's flagship X-ray multi-mirror mission, XMM Newton. The cloud was also seen by the European Southern Observatory's Very Large Telescope Multi-Unit Spectroscopic Explorer, VLT MUSE, and Subaru, Japan's flagship optical telescope. The record-breaking cloud was discovered near the Able 1367 galaxy cluster, also known as the Leo cluster, which is 330 million light-years away from Earth and contains more than 70 known galaxies. If you thought the temperature of the cloud at 10 million degrees was hot, the Leo galaxy cluster can reach 100 million degrees Kelvin, which is insane to say the least. Despite its proximity to the colossal cluster, the orphan cloud is so named because it is not formally associated with any of the galaxies in the Leo cluster, but rather exists in some form of no galaxy's land. The lonely cloud, and others yet to be discovered, according to researchers, could help scientists better understand stripped interstellar mediums at great distances from their galaxies, as well as the effects of turbulence and heat conduction. Platinum and gold are two of the most valuable elements on the planet, with prices per ounce that are close to $1,000. On the other hand, a groundbreaking new discovery about their violent radioactive and cosmic origins may cause their allure to grow stronger while simultaneously making them seem more bizarre. Scientists who were awarded the Nobel Prize for their discovery of gravitational waves, also known as ripples in the fabric of space, have just recently announced that they have made the first detection of the collision of two neutron stars. The group helped astronomers all over the world point their telescopes directly at the scene of the crash and record unprecedented observations of the aftermath in visible light, radio waves, X-rays, and gamma rays after they were informed about the event immediately after it took place. It is believed that these two neutron stars merged together to form a black hole. From this black hole, a fragment of one of the neutron stars managed to escape and form new elements. These elements would later be discovered on planets like Earth. According to astronomer Duncan Brown, a member of the research team, the merger that was detected by astronomers from 130 million light-years away will quite possibly have a bigger impact on science and human understanding in many ways than the first gravitational waves. This was made possible by the Laser Interferometer Gravitational Wave Observatory, and the Virgo interferometer, which is a gravitational wave detector located in Europe. The gravitational wave event, which has been given the name GW170817, is considered to be revolutionary because it sheds light on the process by which many heavy elements were formed in space. For one thing, supernovas, which refers to the explosion of a giant star, are believed to create lighter elements. However, scientists have been wondering for years what explains the abundance of heavy elements. After a great deal of investigation, scientists developed the theory that the collision of two neutron stars would result in the creation of elements with a heavier periodic sequence than nickel and iron, as well as the emission of gravitational waves. It became clear that they had predicted everything correctly. They witnessed this process in action when certain heavy elements were created through a process known as the rapid process, also known as the R process. During this process, two neutrons collide with each other, which results in the release of neutrons with a high amount of energy. These neutrons then collide with one another, which results in the formation of massive atomic cores. On the other hand, these atomic cores split apart into smaller atoms virtually instantaneously. They believed that the kilonova that they observed with GW170817 produced an amount of silver, gold, and platinum equal to approximately $100 octillion worth. With the success of LIGO, efforts are currently being made to improve the technology in order to help reveal more secrets about gravitational waves. According to Brown, we are only at the beginning of gravitational wave astronomy, and we have been rewarded with these incredible discoveries. Using NASA's Hubble Space Telescope, scientists discovered evidence that a planet orbiting a distant star may have lost its atmosphere but gained another through volcanic activity. GJ1132b is thought to have started out as a gaseous world with a thick hydrogen blanket of atmosphere. This so-called sub-Neptune, which began several times the diameter of Earth, is thought to have quickly lost its primordial hydrogen and helium atmosphere due to the intense radiation of the hot young star it orbits. Such a planet would be reduced to a bare core the size of Earth in a short period of time. That's when things started to get interesting. The discoveries may have implications for other exoplanets or planets outside our solar system. How many terrestrial planets don't begin as terrestrials? Some may start as sub-Neptunes, and they become terrestrials through a mechanism that photoevaporates the primordial atmosphere. This process works early in a planet's life when the star is hotter, said lead author Mark Swain of JPL. Then the star cools down and the planet's just sitting there. So you've got this mechanism where you can cook off the atmosphere in the first 100 million years, and then things settle down. And if you can regenerate the atmosphere, maybe you can keep it. In some ways, GJ1132b, located about 41 light-years from Earth, has tantalizing parallels to Earth, but in some ways it is very different. Both are about 4.5 billion years old and have similar densities, sizes, and ages. Both began with a hydrogen-dominated atmosphere and were hot before cooling. The team's findings even suggest that GJ1132b and Earth have similar surface atmospheric pressures, however the planet's formation histories are vastly different. It is not thought that Earth is the surviving core of a sub-Neptune, and Earth keeps a safe distance from our Sun. GJ1132b is so close to its red dwarf star that it completes an orbit around it once every day and a half. This extreme closeness keeps GJ1132b tidally locked, always showing the same face to its star, just as our Moon always keeps one hemisphere permanently facing Earth. The question is, what is keeping the mantle hot enough to remain liquid and power volcanism, Swain wondered. This system is special because it has the opportunity for quite a lot of tidal heating. Tidal heating is a frictional phenomenon that occurs when energy from a planet's orbit and rotation is dispersed as heat within the planet. GJ1132b has an elliptical orbit, which means that the tidal forces acting on it are greater when it is closest to or farthest from its host star. The planet is gravitationally influenced by at least one other planet in the host star's system. As a result of this gravitational pumping, the planet is squeezed or stretched. Tidal heating keeps the mantle liquid for an extended period of time. In our own solar system, a nearby example is Jupiter's moon Io, which has continuous volcanic activity due to a tidal tug-of-war between Jupiter and the neighboring Jovian moons. Given the hot interior of GJ1132b, the team believes the planet's cooler overlying crust is extremely thin, possibly only hundreds of feet thick. That's far too weak to support anything remotely resembling volcanic mountains. Tidal flexing can cause its flat terrain to crack like an eggshell. Such cracks could allow hydrogen and other gases to escape. This exoplanet can be observed by NASA's James Webb Space Telescope. Scientists will be able to see down to the planet's surface thanks to Webb's infrared vision. If there are magma pools or volcanism going on, those areas will be hotter, Swain explained. That will generate more emission, and so they'll be looking potentially at the actual geologic activity, which is exciting. Let's hear your thoughts about these discoveries in the comments down below.